Hello and welcome back, and today we're going to be talking about the Strong Pigeonhole Principle. So you may already know the basic pigeonhole principle, where if you put more pigeons than pigeonholes, at least one hole gets more than one pigeon. But the Strong Pigeonhole Principle goes further. It doesn't just guarantee that some hole gets at least one extra, it tells you exactly how many must be in the fullest hole. And if n objects are placed into k boxes, or you have n pigeons placed into k pigeonholes, and you take the upper value of it, so this is always going to be rounding up, and it's known as the ceiling, then at least one box contains at least the ceiling of n over k objects. So now we have our first question, which is how many seats in a large auditorium have to be occupied to be certain that at least 3 people seated have the same first and last initials. So to break it down, we need to start by finding the total combinations of initials. So we know that there's 26 letters in the alphabet, so there's 26 possible first initials. And you're going to have 26 possible last initials. So the total combinations is going to be 26 times 26, which is 676. This means that we have 676 pigeonholes. So for each possible pair of initials. And now we want to guarantee that some pair of initials appears at least 3 times. So to avoid having 3 in the same hole, we could put at most 2 people in each of the 676 holes, which will give us 2 times 676, which gives us 1,352 people. So this is still possible that there's no initials that repeat 3 times. So, in order to force one more person into a pigeonhole, we just need to add by 1, which gives us 1,352 plus 1, which gives us 1,353, which we could see by the pigeonhole principle as if you take the ceiling of 1,352 divided by 676, this will give us 2 people per pigeonhole. But if we take the ceiling now of 1,353 over 676, it means that we always have to round up. And since this is going to be 2 point something, that means we have to round up to 3. And this is the smallest amount because we know it's only 1 larger than what would give us a value of 2. So therefore, you need 1,353 occupied seats to guarantee that at least 3 people share the same first and last initials. So now we have our second problem, which is how many students must be in a school to guarantee that at least 5 of them were born in the same month. So we're going to set up what our pigeonholes are and what our pigeons are. So the pigeons are going to be the students, since that's who we're trying to put into groups. And then the pigeonholes are going to be the 12 months of the year. And then we want to force at least 1 month to have 5 students. So the first thing we're going to do is max out how many students. We're going to max out what the number of students we can have if no month has 5 students. So here we need each month that can have at most 4 students. So max number of students without hitting 5 in any month is 12, so the number of pigeonholes multiplied by 4, which means that we're going to have 4 students in each pigeonhole. So this is going to give us 48. So with 48 students, it's possible that each month has exactly 4 students, and no month has 5 yet. Now, since this is our maximum, if we add 1 to it, which is our 48 plus 1, to get 49, this means that at least 1 student must go into the 12 months and now have 5 students, which we can see because if we take again the ceiling of 48 over 12, that gives us 4. But now if you take the ceiling of 49 over 12, this will round up to 5, meaning that in one of the holes there has to be at least 5 students. Therefore, you need 49 students to guarantee that at least 5 of them were born in the same month. Thank you for watching. If you enjoyed and want more combinatorics questions, please let me know what else you'd like to see, and I'll see you in the next one.